Alright, so here we're going to talk about polynomials and polynomial functions. So we can name a polynomial based on its terms and degrees. A number or a term is a number or the product of a number, one or more variables raised to the powers. If a term only is a number, it's called a constant. And a polynomial is defined as a finite sum of terms in which all variables are raised to a non-negative integer. So just an example of something that is not a polynomial would be something like x squared plus x to the negative 1 plus 1, or x squared plus x to the 1/2 plus 1. So because this is a negative 1 and this is a fraction, those would not be polynomials. Alright, example number 1 says, determine the number of terms of each polynomial. So each term is separated by a plus or a minus. So this first one has 3 terms. Okay, and then this next one, first thing I'm going to do is I'm just going to rearrange it from highest to lowest to make sure it's in standard form and to make sure that I can't simplify anything else. So this one has 4 terms. This one's only 1, so it has 1 term. And we call this a constant. So remember, a number by itself, it's just a constant. And the degree of a term is the sum of the exponents on the variables contained in that term. So we could say that the number of terms and name based on the number of terms. So we're going to have, if it has 1 term, it's a monomial. If it has 2 terms, it's a binomial. If it has 3 terms, it's a trinomial. And if it has 4 terms or higher, we'll just say polynomial of blank terms. Alright, so here we have a polynomial, and it is 3x squared y plus 4x cubed y plus 4x squared. And we're going to go ahead and find the degree of each term. So we have 1 term here, here's another term, and then here's the last term. So I'm going to go ahead and separate this. I'll write that there, that in the middle, and that one all the way over here. So to find the degrees of each one of these terms, so 3 terms, right? We just add the exponents. So this one would be, there's a 1 there, degree 3. This one would be degree 4. And then this one, there's only a 2 there, so that would be degree 2. Now, the degree of a polynomial is going to be the largest degree of all its terms. So, out of these 3 degrees, the one that's the highest is the 4. So the polynomial has degree 4. Okay, so each term has a degree, but then the highest of those degrees is the degree of the polynomial. Alright, and same thing for a polynomial. We could name it based on its degrees. So if it has degree 0, it's called a constant. Degree 1 is a linear. Degree 2 is a quadratic. Degree 3 is a cubic. Degree 4 is a quartic. And degree 5 is a quintic. And we could name them now based on their degrees. So we're going to go ahead and classify the polynomial by degree and terms. So here we have, here we have 1, 2, 3. So I'm going to say 3 terms. And this one's a little bit easier because you only have one variable. So in this case, you just have to look at the highest degree, which is 3. So degree 3. So for degree 3, we call it a cubic. And with 3 terms, we call it a trinomial. Alright, so this is a cubic trinomial. Alright, the next one, it only has one term. And that one term, its degree is, you add up all the exponents, so that would be 1 plus 1 plus 1, 3. So that's degree 3. So this is a cubic monomial. All right, next we're going to go ahead and evaluate. So example number 4 says, if p of x is equal to 3x squared minus 2x minus 5, find the following. P of 1. So what this means is for every x value, you're going to plug in a 1. So that would be 3 times 1 squared minus 2 times 1 minus 5. And then we're going to go ahead and simplify this. So this is 3 times 1, 3, minus 2, minus 5. So that gives you, this gives you 1. 1 minus 5 is negative 4. Alright, next thing you're going to do is same thing, but now you have a negative 2. So x is equal to negative 2. So wherever you see an x, you're going to plug in negative 2. Alright, so this gives you 3 times 4 plus 4 minus 5. So this gives you 12 plus 4 minus 5. So if you add that up, it gives you 11. Alright, the last thing we're going to do is we're going to add and subtract polynomials. So when you add and subtract polynomials, the only thing you have to be careful to do is add like terms. So I'm going to start off with this first one. I have an 11x cubed, and I have to look for if there's any other cubics. Here's another cubic. So I'm going to add those up, and I get 12x to the third, and then I'm going to move to the next one. So I get an x squared. I'm going to look for any other x squareds. No, I don't see any. Okay, then I'm going to do the next one. I have an x, and then I have a negative 10x. So those are like terms. I could go ahead and add those. And lastly, the numbers. You got to add those. So you get a plus 2. So that would be your answer there. Alright, and we're going to do the same thing for the next one. So the next one, it has 2 variables. So you have to be very, very careful. This first one has 7x to the third y. So you look for another term that has x to the third y. So that's this one right here. So if you add those up together, you get 13. So 13x to the third y. So notice only the coefficient changes, but the variables stay the same. Then you have x y to the third, but you have no other one that has x y to the third. So you just write that down. And lastly, you have your numbers here. So you could combine those and you would get 7. And that would be your answer. Alright, so that's adding. Subtracting just is one more step. So if you are subtracting these, before you move on, you do have to distribute this negative here to every single term in the second parentheses. So I'm going to go ahead and rewrite this. 12z to the fifth minus 12z to the third plus z plus 3z to the 4 minus z to the third minus 12z, and then now we could go ahead and add like terms. There's no other 12z to the fifth, so we're going to go ahead and write that down. And we could combine these two because they're both z to the third. So that gives you negative 13 z to the third. And then we have these z's right here. So that gives you a minus 11z. And the last thing is the z to the fourth, which I should have put it in there, but I could rearrange things. Alright, so let's just rearrange this to make it in standard form. So standard form is from highest to lowest. So the highest exponent is the 5, and then would come the 4, the 3, and then the first, because I don't have a second. So that would be your answer.